Okay, so another topic that will likely come up in paper 2 is parametric integration, right? So let's get started with part A. In this question, they want us to prove that the shaded area R is given by this integral, right? Now this integral, how can we get to that? Well, with parametric integration, we know that the integral is given by y multiplied by dx over dt, right? Now y we already know, dx over dt we don't know, so we need to find it out. So x is going to be equal to 8 sine squared t, right? Now dx over dt is what we want. To find that out, we're going to need to use chain rule. To do the chain rule, I'm going to rewrite this to make things easier to visualize. So 8 sine, I'll write this in bracket, all squared. Can you see here how the sine has a power of 2? So all we need to do is 8 times 2 times sine of t, right? So that will just leave us with cos of t. And then times it by the bracket inside the bracket, right? And then what you do to the bracket is you remove the power by 1, right? So it's going to be sine of t alone. So it's just, we're just left with 16 sine t cos of t. And that's it. Now, the integral can be written as y, so that was 2 sine 2t plus 3 sine of t multiplied by our derivative, which we just found. So that would be 16 sine t cos t dt, right? Now, 16 sine t cos t, I can rewrite that as 8 sine 2t. So if I write that in the integral, we're left with 2 sine 2t plus 3 sine t multiplied by 8 sine 2t dt. Now if I expand this out, we're going to be left with 16, so integral of 16 sine squared 2t plus 24 sine 2t sine t dt, right? Now the sine squared 2t, we want cos 4t somehow from that, right? So we're going to need to use the double angle formula for cos now. So double angle formula for cos 2 of t is, which one involves sine? It's going to be 1 minus 2 sine squared t, right? Now for cos 4t, we can say it's 1 minus 2 sine squared 2t, right? So I can sub that in now. So if I plug that in, we're going to be left with 8 minus, so integral of 8 minus 8 cos 4t plus 24 sine 2t sine t, right? dt. Now this sine 2t, that's the same thing as writing 24 times sine 2t is 2 lots of sine t cos t. So I need to times that out by the sine t. So if we write that all together, we're left with 8 minus 8 cos 4t in bracket plus 2 times 24, that's 48, multiplied by sine squared t cos of t, right? Close the bracket, we have dt. Now the bounds is all we have left to plug in. The bounds, how do we work that out? Well, we know x is equal to 4, x is 0. For the bound being 0, we don't need to change anything. But for 4, we need to find out what is t. So we need to use this equation. X is equal to 8 sine squared t. So x equals 8 sine squared t, right? So 4 equals 8 sine squared t. So 4 over 8 equals sine squared t. So sine of t is equal to root 1 over 2. So t equals arc sine of 1 over 2, root 1 over 2, which is 1 over 4 pi. So then our integral would just be the bounds being 1 over 4 pi and 0 and 8 minus 8 cos 4t plus 48, what was it, it was 48 sine squared t cos t. Now write this all in brackets, dt. Is that what the question wanted? Yep. Okay, so part B for this question wants us to find the exact area of R, right? So all we need to use is the integral from part A. So if we look at our integral, it's 8 minus 8 cos 4t plus 48 sine squared t cos t. The 8 minus 8 cos 4t is simple integration, so we'll deal with the 48 sine squared t cos t first, right? So I'm going to split this integration up. So I'm going to be, right, 48 sine squared t cos t dt is our integral now. 1 over 4 pi remains the same and 0 is the exact same too. So this integral we're going to need to use u sub. So if we use u is equal to sine squared t and du over dt, what would that be equal to? Well, we just use the chain rule, right? So bring the power down and times by the derivative. So sine t cos t, right? So now rearrange for dt. So du over 2 sine t cos t is equal to dt. Now if I plug this back into our integral, well, we're left with what? 1 over 4 pi 0 and then 48 u cos t times by du over 2 sine t cos t. And you can immediately see the cos t's, they just cancel out, right? Now sine t, how can I rewrite that? Sine t is the same thing as u to the power of a half. It's the square root of u, because u is just equal to sine squared t. So our integral is going to be 1 over 4 pi 0 48 u times by du over 2u to the power of a half, right? So then we can rewrite this as 1 over 4 pi 0 then 24 u to the power of a half, right? Du. Now the integral of this is just going to be 24 u to the power of half. So we add 1 to the power, so it's going to be u to the power of 3 over 2. And then it's going to be 24 divided by that 3 over 2. So that's going to be 48 over 3. And the bounds would remain 1 over 4 pi. Now, it's inaccurate to say the bounds are 1 over 4 pi, but I'm simply saying this because I'm going to sub u back into sine squared t back into u. Okay, so now if we look at our integral, let's sub in that u. So 48 over 3 times by sine squared t, and was it to the power of 3 over 2? So sine squared t to the power of 3 over 2 with the bounds 1 over 4 pi and 0, right? Now sine squared t to the power of 1 over sine squared t to the power of 3 over 2, right? So now we square root it and we cube it, so it's just going to be left as sine cube t. So it's going to be 48 over 3 sine cube t with the bounds 1 over 4 pi and 0. So if I sub those in, so 48 over 3 sine cubed 1 over 4 pi, right? Now if I put that in the calculator, what's that going to be? Remember to do it in radians as well. So we're left with 4 root 2, right? And if we sub in the 0, that's just going to be minus 0. So if we just look at the 48 over 3 sine cube t, that term gives us 4 root 2. But we're not done with the question. Now we need to look at the other part of the integral, so the simpler part. So we got the hard stuff out the way. So it's just going to be 8 minus 8 cos 4t. It's going to be 8 minus 8 cos 4t, right? Now we're looking at the integral for this. So 1 over 4 pi is still our bounds. And dt. And in this case, we don't need to do dt. This is just simple integration. So this is just going to be 8t minus 8 over 4 cos, not cos, sine 4t. Right? And then the bounds remain the same, 1 over 4 pi and 0. Right? So 8t. If I sub in 1 over 4 pi, or we'll write it out first, 1 over 4 pi minus 2 sine pi as our bounds. So now minus that 0 as well. So 8, 1 over 4 pi. So that's just going to be 2 pi minus 2 sine pi. So if we put that in the calculator, that's just going to be 2 sine of pi, which is 0. So 2 pi minus 0. So then if we look at our integral, it's just going to be this 4 root 2 plus that 2 pi. So 4 root 2 plus 2 pi. And that's our whole integral completed. So r is equal to 4 root 2 plus 2 pi. That's it. And we leave it as that. We leave it in terms of pi because they wanted it in exact form.